Hey there, welcome to WEBfactory. I'm Alex, and this time we're talking about signal value logging in i4SCADA Studio. If you're not familiar with i4SCADA Studio, I suggest you check out our other videos in this playlist. Also, subscribe to our channel, enable the notifications, and get more instructional videos like this on the WEBfactory's Industry 4.0 solutions. First, let's discuss about logging. i4SCADA Studio allows you to set up this recording of signal values based on computable conditions, called signal logging. This is a central part of Studio and it's available in its dedicated section. As the user interface suggests, the logging action is defined in two steps: the condition that, when satisfied, triggers the logging action, and the logging action itself. Let me explain using an example. The first logical step is to define the log condition. This is the main prerequisite of logging signal values, and i4SCADA Studio allows us to define a bunch of them and use them to trigger our logging. Using the already familiar interface, I'm gonna create a new log condition on my SCADA server. This new condition will be available to all logging we define on this server. There are a few properties defining a log condition: the condition's name, and the properties used to compose the computational logic of the condition. The most important of them is log mode. This property allows you to select one of the predefined modes or triggers, while the rest of the properties are used to configure the selected log mode. Let's go through log modes one by one. Time triggered allows you to set up a log interval for triggering the signal value logging. This interval can be set from 1 second up to 1 day with highly granular increments. Notice how only the properties used by the selected log mode are active in the condition details panel. Time triggered when signal value is greater or smaller than a constant allows you to build upon the time triggered mode by logging the value at the specified time interval, but adding another conditional step which compares the value of our logged signal to a defined log constant. So our log is triggered at the defined interval only if the signal value is higher or lower than the constant we define. Time triggered when signal value is greater or smaller than another signal value. Just like the previous mode, it adds another conditional step to the time triggered mode, this time comparing the value of our logged signal with another signal value. We can select this second signal used in the computation using the signal value to property. The next log mode is somehow a combination of the previous two, allowing us to trigger the signal logging at a specified time interval, but only upon validating the comparison between a secondary signal value and a constant. These time-triggered modes will log the signal value at a given interval, no matter if the signal value has changed or not. The next modes, starting with only on change, will not use a time interval as a trigger, but the actual change of value in the signal to be logged. For example, only on change will trigger the signal value logging whenever the value changes. As with the time triggered, we can expand on this logic and add additional condition steps. We can trigger the logging when the signal value changes and the new value is greater or lower than a constant. We can also compare the changed signal value with a secondary signal value, or we can compare the secondary signal value with a log constant. Mean value and counter mean value log modes will trigger the signal logging similar to the time triggered. The logging will happen once in a cycle defined by a log interval, but the value logged will not be the actual signal value at the time of logging. Mean value will use the report interval property to define a time interval and log the average of the values read in that time interval. Counter mean value will also log the average value of our signal, but computed using all recorded signal values. The last log modes are only triggering the signal logging once, without using a cyclic time interval or monitoring the change of value in the log signal. Instead, the stored once modes will use the comparison between a secondary signal and a log constant, or monitor the change of value of the secondary signal to trigger the logging. The last two log condition properties are inactivity interval and is-relative inactivity interval. These two properties apply to only on-change log modes. Inactivity interval defines a time interval in which the last signal value will be repeated if no signal updates occur. When defined mainly for signals with long or irregular update times, the i4SCADA server will emit the last recorded signal value at every cycle defined by the inactivity interval value until a new signal value is registered. This means that the only on-change log modes will pick up the repeated value every cycle just like the value would have changed. The isRelative inactivity interval affects the beginning of the inactivity interval cycle. If disabled, the inactivity interval is calculated starting with the first second of the current day. If enabled, the inactivity interval is calculated starting with each signal value update. Thus, relative means relative to the last signal value update. Now that we understand how log conditions work, let's define the actual log to be triggered by our condition. Under the logging section, I'll define a new log on my SCADA server. I'll select the signal that I want to log and confirm it. My new log's properties are available in the logging details panel. Log tag, which is the name of my new log, signal name, the signal for which I want to log the values, the log's description, condition name, which allows me to select the trigger of the log. This is where I'll choose the condition that we've just created. Max days lets me define a maximum number of days that my logs will be kept. Logged values that are older than this value will be deleted. Max numbers lets me define the maximum number of logged values. Once exceeded, the existing log values will be deleted, starting with the ones first recorded. Log database lets me define a custom name for the database table where my signal values are going to be stored. IoT enabled marks the log as an IoT compatible log that can be accessed using the IoT hub. So once our log is defined and saved, as long as the i4SCADA server is running, the values of our selected signal will be logged based on the employed condition. The logged values are available in the database, and the logging procedure itself can be observed using Activity Analyzer. This wraps up our video on i4SCADA Studio logging. I hope you've gained some helpful insight that will aid you in your i4SCADA journey. Keep an eye on our YouTube channel for more videos like this one. I'm Alex, this is WEBfactory, and until next time, stay safe.